Okay, here we go. Unit 9, hypothesis testing. This is review B. So notice that on these reviews and also on the test, they're not going to straight up tell you with like a title or something of what type of problem that you're going to be dealing with. Again, the three different types of problems that we have to do in these problems are problems that involve sigmas, problems that involve s's, and then problems that involve probabilities. Again, if they give you a sigma, you're finding a z, and if you have a probability, you're finding a z. And then if you have an s, then you're going to be finding a t. So it's kind of up to you to determine which is the correct path to go down when you read the problem itself. So looking at this problem, just looking at it, I see a bunch of like percentages and things like that. So this is most likely a probability problem. But let's just read it just to make sure, and we start the problem off properly. What is your favorite color? A large survey of countries, including the United States, China, Russia, France, Turkey, Kenya, and others indicated that the most people prefer the color blue. In fact, about 24% of the population claim blue as their favorite color. Suppose a random sample of 56 college students were surveyed, and 12 of them said that blue is their favorite color. Does this information imply that the color preference of all college students is different, okay, from the general population? Use a level of significance of 5%. So yes, indeed, this is a probability problem. Okay, so the probability that we accept is that 24% of people like the color blue. So that is what, 0.24. So from here we get a Q, which is 1 minus P, and that would be what, 0.76. We took a sample and we saw that of 56 was our sample size. And we saw that 12 of them like the color blue. So of our sample, the probability of people liking blue, which is R divided by N, is going to be 12 out of 56, 2, 1, 4, 3. And then what we're figuring out has a level of significance of 5%. All right, notice that we're looking for different. So that is going to be a two-tail with an is not equal to. Okay, so the null hypothesis. The null hypothesis says that the probability of liking the color blue is 24%. And we just did a sample, and we want to show that it is not equal to 24%. Don't care if it's bigger or smaller, as long as it's not equal to. The level of significance in this situation is 5%. And we see that this is a two-tail. All right. Because we're dealing with probabilities, this is going to be a z-score, which is a standard normal. Which has a z of p hat minus p divided by pq divided by n square rooted. It's best to have parentheses around the numerator and on the inside of that denominator. So here we go. The numerator is p hat minus p divided by the square root of, open a parentheses, pq divided by n, and again, that close down that parentheses. Z of negative 0.45. Okay, so we create this into a p-value. So this is a z of negative 0.45. Also note that this is a two-tail. A z2 tail indicates that we are going to have to double this p-value. So negative 0.45. Let's go ahead. This is going to be do not reject. So negative 0.45. Negative 0.45. 3264. But because this is a two-tail and this is a z, we have to do the work, and we multiply by 2. Huge z-score. This is a absolutely do not reject. All right, so here we go. So this is our picture. This is a two-tail, so the rejection zones are technically on both sides. They have a level of alpha, which in this case is 5%. And this one technically is on the left-hand side because it's a negative z-score. I don't really mind, but it's technically on the left-hand side. It's a negative z-score, and you see that the p-value is way larger than the alpha. Alpha is 0.05. Our p-value is 0.6. It's like way bigger. So it's way into this do not reject zone. And absolutely bigger than the alpha. So that means that the p-value is greater than the alpha. That means do not reject H0. That means we do not have enough evidence to say H1. We do not have enough evidence to say H1. H1 says the probability is 91 to 24%. So we do not have enough evidence to say H1. So the probability, add context, is not equal to 24%. Probability, I totally forget what we're talking about here. The favorite color is blue. As their favorite color, it's implied. Probability, favorite color blue, is not equal to 24%. We just don't have enough evidence. It might not be true, but we just can't. We don't have enough evidence to say that it's not. We do not have enough evidence to say the probability of a person liking the color blue is not equal to 24%. Okay, in this problem, they give me an X bar here. They give me a sigma. Okay, so that's the indicator. They're saying that the average should be 85. Is it quote unquote higher than 85, 5%? And I need a sample size, and so that's going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 is my sample size. Okay, so let's pick out the important information. So we see that the average should be 85. Our sample says that it's 93.8. The standard deviation, that is a sigma of 12.5, so this is going to be a z, a standard normal z. A sample size of 8. And an alpha of 5%. Okay, so starting this problem, see that the null hypothesis is that the average is 85. Okay. Our alternate hypothesis is it higher than 85? Is it larger than 85? The level of significance is 5%. And this is a right tail. Okay, because this does have a sigma, this is going to be a standard normal. Which means z, and the one using the sigma is x bar minus mu of sigma divided by the root of n. And again, with this, we have parentheses around the complete top and the complete bottom. .99. So my p-value is based upon a z of 1.99. Always look that up as a negative. This is not a two-tail, so I don't have to multiply by 2. All I straight up have to do is just look it up. So 1.99. So we have 1.9. Oh, shoot. I'm sorry. Look it up as a negative. Oh, better than that. Sorry. Negative 1.990233. Again, this is not a two-tail. This is just one tail. A right tail, more specifically. Okay, so right tail means the rejection zone is on the right. This is alpha of, I think, 5%, right? Yeah, 5%. So putting the p-value on that, I notice that the p-value is way smaller, so the distance from the edge is shorter, so it doesn't get as far as the do not reject. So the p-value is smaller, so that's 0.233. It's shorter from the edge. So I notice that my p-value is less than my alpha. That means reject H naught and accept H1. And now when this is the answer, this is exactly what I say. So I saw that H naught is that the average is equal to 85, and H1 says that the average is greater than 85. Okay, so I don't even know what 85 is. Is that like height of horse or something like that? The mean glucose level. All right, the average glucose level, their blood sugar. Okay. So, all right, here we go. So we reject H naught. Okay, so the average glucose level So we reject that the average is equal to 85 and accept the average is greater than 85. So this is the one that I'm assuming is an S. We know it is. All right, so we have an average, we have an S, 31 patients, sample average, 5%. Has it changed the mean, aka is it not equal to? I don't care if it gets bigger or smaller, this is saying is it not equal to? Has it changed the mean? Okay, so here we go. The average is supposed to be 7.4. My sample is showing 8.1 and has a sample standard deviation of 1.9. Because it's an S, this is going to be a student's T, finding a T value. This has a sample size of 31 patients, and we want a level of significance of 5%. All right. So our null hypothesis in this situation is that the average is 7.4. And our alternate hypothesis is saying that it is changed. It is not 7.4 anymore. Okay, this is a level of significance of 5%. And this, again, is a two-tail. All right, because this is an S, this is going to be a student's T. And that means T is going to be equal to X bar minus mu of S divided by the root of N. Again, make sure you have the top and the bottom completely in their own parentheses. So X bar minus mu divided by S divided by the square root of N. This is a T, so I run out the decimal on this one. Keep some of that. So here we go with the p-value. This is built upon a T. So because I have to use the T-table, I also need the degree of freedom, which is n minus 1. So this is going to be a degree of freedom of 30. Okay, so 32.0513. Is it 2.50? I totally forget the number. 2.051. 051. Thank goodness I looked. I guess it's up on my calculator. And notice. All right, so degree of freedom of 30. Looking for 2.05. 2.05. It's right in here. It's in between those two numbers right there. 2.042 or 2.04. Yeah, 2.042. And 2.457. Okay, so I noticed that it's in between those two. 2.05 is bigger than 0.4 and it's less than 0.45. And so the p-value, this is a one-tail, no, it's a two-tail, excuse me, I'm sorry. This is a two-tail, so the two-tail level is right there, so don't be looking at that top one, that's the one-tail. So the two-tail level of these dudes is 0.5 and 0.2. Okay, so we have a line right here, and I'll show you what to do. Okay, so go to the picture. I don't think we've seen one of these before, and here's what we haven't seen. So this is a two-tail, and alphas are 5%. Yeah, 5%. Okay, now, as I said, the p-value is equal to, look at the very first p-value. The very first p-value is 0.050. So that means one of them is right on that line. Okay, and this is the kind that we haven't seen before. We haven't seen where one falls on the line. And that's fine. But mathematically, though, this 0.50 is exactly what 0.42 is. All right, and notice that our p-value is not 0.042 exactly. All right, it's 0.045. So what it's saying is this. It's technically not equal to this, and it's not equal to this. It is literally in between those two. So how to simplify this, and what do you need to have on your answer? That's probably what you're concerned about. Here's what you need. If you have a liner, like one that is on the line, my advice is reference the other number as your p-value. So if 0.5 is on the line, take a look at the other one. The other one is 0.2. Well, where is 0.2 in reference to that? So if one's on the line, the 0.2 is saying, okay, it's smaller. And so that is exactly what we run off of. Okay, because it's a liner, what we do is we run with the other one. Because again, technically, it's somewhere in between these two lines. Right? So it's technically, I don't know, there or something. I don't know exactly where it is, but it's somewhere in between the two. So it's definitely smaller than the alpha. All right, so what are we talking about here? 7.4 is not equal to 7.4. And what is 7.4? Let's read the question here. For healthy adults, mean acidity level, the mean acidity level, the average acidity level. So we reject that the average acidity level is equal to 7.4 and accept the average, I already described what it is not equal to 7.4. So we reject that the average is equal to 7.4 and accept that the average is not equal to 7.4. Just say the words. Interpret the symbols into English words. And that's all you got to do.